Eddie, am I live? Hey everyone, here for a live stream today. Our discussion is for a new series that we're experimenting with called Chats at the Edge. And I'm joined for these discussions, my colleague in the biz and one of the people I really respect in this space, Keith Townsend,
Alex,
CPO advisor.
And it's good to see you virtually, and I'm a little bit on edge about these chats on the edge, man. This is an exciting topic we chose for the first chat.
Yeah, so today we're going to talk about SmartNICs, networking and service mesh, and it's an interesting space. And the way I've been describing it as what we're trying to do here as part of a program that Keith and I are involved with at Intel. So Intel is definitely a big part of this project. I just want to give a shout out to them. But this the discussion here, I think over the next several months for us will be about that intersection of hardware and software and how that plays a role in application development. And Keith comes from a deep history and background in working in data center operations and data center management. And now as one of the most respected people in the world of understanding how data centers work, but taking it from an analyst perspective. And so Keith, you can do more justice than I can. So perhaps you could explain a little bit about your work and we can just get started.
Yeah, so a couple of years ago, after leaving VMware for a short stint, I decided to rejoin the analyst world. And one of the things that we really wanted to tackle from a content perspective is, we kind of learned something from the new stack. You guys hired some deep technical experts to create content that really talked to the practitioner. And what we noticed was that there wasn't a lot of that conversation happening around this intersection of the physical data center and cloud. From the abstract, we kind of know that the two complement each other, but like, what does it physically look like? So we built the data center. Intel has sponsored that data center. And as a result, we want to create content that talks about practicals. What does it mean that SmartNICs and service meshes should somehow become a thing that developers and IT infrastructure practitioners should care about?
Great. And so again, the topic is on SmartNICs, service mesh and networking, and it follows the news from VMworld last week. And VMware announced Project Monterey, which for me really fulfills their first efforts into moving more towards a cloud-native environment for vSphere, and that came with Project Pacific and VMware Foundation. And Project Pacific is bringing Kubernetes really into the main stage for VMware, and they've called out Intel as one of their partners, and Intel is focusing a lot on this SmartNIC environment. And perhaps you could just give your thoughts on the news, and then we can then move into the discussions about the larger story, because I've had some conversations over the past few weeks with some people who've talked about really the extension of service mesh into other cloud native realms, such as Cilium, which is a project that I think is really interesting in other projects as well. So love to hear your thoughts on the show and the news from Intel and VMware.
So the thoughts on the overall news. VMware a couple of years ago did a really cool nerdy thing of running VMware ESXi, their hypervisor, on a SmartNIC. SmartNICs have ARM processors for the most part on them. That's generally the architectural platform, which is weird seeing that Intel is sponsoring this conversation. But and what we thought this would take us is to this point where VMware would be able to run data center workloads on a NIC, and everyone kind of scratched their head like, why would I need a data center workload running on a NIC? Well, VMware took the abstraction one point further, which developers should be able to relate to this. If you look at what AWS does with AWS Nitro, very same concept where they extend the hypervisor functions out to the SmartNICs. That alleviates some of the pressure on the overall resources, improves or the overall x86 resources of physical servers, and improves overall performance and reduces the cost. Data centers will magically get that increase in performance because VMware vSAN, VMware NSX, all of these data center overheads that x86 has been great at abstracting, but has come at the cost of server x86 overhead. These Intel NICs and VMware partners will lighten the load. They'll be able to run these storage functions. They'll be able to run these networking functions directly on the SmartNICs, and you get better application performance, and you end up getting better server utilization. So it should be a win for everyone. We'll get into maybe later on the conversation specifically around telco providers and the advantage for telco providers if you're in the telco provider space. But that's kind of, I think for both me and you, that's more of a secondary audience.
Right. It is yeah. And so, going back to what, maybe we could get into a little bit of that historical look at things. As you were saying, AWS began running on Nitro. And there were a few reasons for it, in particular, security and the isolation that you could get from it. And what is apparent, I think, with the VMware news is that we are starting to see this requirement that the hyperscale service providers have had for some time. And that's some capability also to offloading, some of this overhead, so the networking requirements. For instance, I think around matters such as identity, for instance, and secrets management and such. And so now we're seeing it move into the second and third tiers of the data center providers out there. I spoke with Kit from VMware, and I'm just there's another Kit out in the world who I always mix him up with.
I know Kit Colbert is the one from
Kit Colbert,
yeah.
Right? Kit Colbert, and Kit was talking about, there are more companies out there that are starting to have similar data issues that hyperscale providers have had. And so what SmartNICs can do is provide some of the advantages that hyperscale providers have had for some time. Maybe you could help us understand what are some of those advantages that come.
Yeah, so some of the things that we love about AWS is the ability to kind of know our data is encrypted. There's really not anything that we need to do. We don't, in the data center, we have to worry about things like data deduplication, all these technical things that make a data center run well. From a service provider perspective, if I wanted to offer end-to-end encryption, how is that done? I either have to do it on the storage array, or I have to do it at the application layer inside of the OS. So that means overhead. From a customer perspective, when I don't have visibility into your individual VM, I don't know what traffic is flowing from your VM that's in your compartmentalized secure enclave going into my storage array. That means that I have to, when it hits the storage array, encrypt it. Well, what about the data in transit? Yeah, sure, there's IPsec and TLS and all of that. What if I could simply, as the storage, as I'm commuting iSCSI or NFS to the storage array or to the hyperconverts, bring your own disk. What if the controller on the SmartNIC did all that encryption for me? What if I could dedupe at the SmartNIC layer? I can offer better and faster services, more secure services to my customers just from a physical underlay perspective. We're not even getting into any acceleration or anything like that. Just from me running a better data center, I'm able to compete with AWS more on price, because AWS, if you've been to these secondary markets, AWS is just killing a lot of these providers when it comes to cost because of this efficiency they get at the x86 perspective. So you would see advantages that kind of levels the playing field, if you could level the playing field between the tier 2 providers and the AWSs of the world. So specifically around VMware Cloud, a lot of folks consume these second tier cloud providers, VMware Cloud solutions. These are all advantages from a Project Monterey perspective. They'll come directly to these types of providers as they offer, whether it's hosted vSphere or some SaaS or IaaS offering on top of hosted vSphere.
And the idea here, in many respects, for developers at least, is to improve performance, to make it, for me at least, is like what it reminds me of container technologies, which allowed you to iterate more, right? So the risk was less. You didn't have a tightly coupled environment that would require long cycles. You could do things relatively quickly, and that seems to be what VMware is seeing as an opportunity here. In my conversation with Kit earlier today, he talked about this, about how Monterey is in support of everything that that developers want, right? It's moving on top of vSphere, on top of the VMware Cloud Foundation, and it also though provides that capability, just to be more, to be able to use cloud native technologies and also be able to use Kubernetes to spread out into other open source projects, and actually allow it to extend into the telco world and such, where maybe open source isn't so well known, but Kubernetes is better known.
Yeah, so a great example of that. So as we talk about this higher level that Kit is talking about, and to your earlier connection with Project Pacific, VMware is moving to a point where Kubernetes is becoming the control plane for vSphere, where VM versus container is no longer a conversation. That's an implementation detail. From a developer perspective, I just want to write code that uses IT infrastructure technologies and underlays, but I don't want to worry about, is this running on a GPU, CPU, is this running at the edge, etc. I want my operations team to figure this out. This draws closer to that dream. Monterey, for example, has the ability to run bare metal workloads on a SmartNIC. So I can run a Windows installation or a Linux installation on a SmartNIC, and that's orchestrated by VMware Cloud Foundation, or AKA Kubernetes. Project Monterey and Project Pacific join together to give the developer the full range of the data center without knowing the implementation details. Maybe I describe at some point, I want a FPGA. I want to be whatever the abstraction is or the control plane language to say this in Kubernetes. I want to use FPGA type performance. I have this type of floating point problem, or I have this thing that this algorithm that could really benefit from a FPGA or GPU versus a CPU. A developer doesn't have to code to CUDA codes or whatever. He just describes what he wants. And then Project Monterey in Pacific magically, it doesn't happen today, but at some point magically just figures that out. This is stuff that AWS can do today, but cloud providers, just second tier level cloud providers will be able to do tomorrow.
Exactly. Well, let's move into the service mesh part of the discussion. And one of the discussions I have was really about the ability to create cryptographic identity does have its advantages. And what this means is that you can start to think about offloading the security and some of the security requirements around identity, onto a SmartNIC. And so if you can have then the SmartNIC then on a machine, and then that machine can connect to other machines, for instance, this allows you to have a level of security that's just basically, in that box. Is that to me seems like a kind of a core aspect of the SmartNIC capability that gets us into thinking about how service meshes, could be thought of maybe even a bit differently than they are now.
Yeah, so I had this really, I don't know if it's obscure, because I think the use case is going to be more and more relevant as the enterprise wakes up more to hybrid cloud types of applications. But I think this is fairly easy to grasp from a workflow perspective. Let's say that you have a Oracle database on premises, and that Oracle database is your traditional SAP type of application, something that's furthest from cloud native that you can get, but the data inside is extremely valuable, and you want to build an application around that, a cloud native application or a native cloud application. Let's say you want to use Lambda functions up against that Oracle database. That sounds like a reasonable thing. I want to write every time this event happens, I want to generate a report that kicks back information. I want to create a query that kicks back information to the user via a Lambda function. Okay, that kind of makes sense. The SAP people don't have to change the way that they create applications. And my cloud native new cloud first developers don't have to learn SAP. They just have to query the database. They know how to do that. However, this is where the hybrid security and problem come in. Firewalls work via IP addresses, and servers. Firewalls don't have this concept of serverless.
Right.
Like there's an IP address, there's a source, there's a destination, there's a port. I can block on that port. Lambda is a serverless instance. I'd have to either allow Lambda or I don't allow Lambda. Wait, hold on. That's not something that I'm used to saying. Where we start to mix hardware and software into the situation, into the solution, is that one, I can secure my legacy app at the OS layer. I can say every bit of data coming out of this application is encrypted. I can have that, and this is getting really far ahead of the thing. This is a way to build this type of application. Really smart people that will do this and live will probably correct me and do it correctly, but technically this is all possible. Everything that leaves the OS, including my SAP, my mainframe applications, etc., is encrypted. That stuff talks to a Istio or service mesh type of thing. That connection is secure. So even if my application doesn't know how to secure it, my cryptography on the SmartNIC does, and I'm establishing the connectivity with the service mesh from a physical network perspective, and Lambda is making calls to the service mesh instead of making calls directly to the application. Some variation it sounds complicated. That's an oversimplification of it. There's a lot of details in it, but these are the types of ways that we can abstract the physical data center and provide secure cloud-like TLS encryption into the public cloud without going back and changing the architecture of these applications that we can't touch or change.
So I was talking with Andres Vega, and he's a product line manager for VMware Foundation, and he's the former open source manager at Sitel, which was acquired by HPE in April.
We
2009.
Super smart.
Yeah. And Sitel is now Project Cosinio, which is based on SPIFFE and Spire, which are projects in the Cloud Native Computing Foundation. And one of the things that they did was, and what I think Project Cosinio is trying to do is provide this federated identity to distributed architectures.
Mm-hmm.
And so Cosinio is that authentication layer to support zero trust between services running on hybrid enterprise IT infrastructure. And it's fascinating to me because this seems to be like the start of what he shared a term with me. I can't recall if I've ever heard it, but this idea of crypto operations. And in his view, the edge is changing how data center architectures are perceived. Running a node at the edge is more common. The question becomes about the node and how it is co-locating as a multi-tenant device. And so you add complexity to that, like the challenges for how to manage a node that may be accessed by any number of organizations, right? And so with this level of complexity, then SmartNICs do become an advantage. And it does allow for ways to offload the constraints that come with identity and IP-based environments. And with SmartNICs, hardware then becomes the root of trust. And it goes back to what I was saying earlier about each box that has a SmartNIC on it can act as kind of a conduit in itself. And so one of the points he makes is about how that's going to change service mesh in general and how we're going to think about service mesh. But I'm wondering if you have any thoughts and perspectives on what he's saying here, because it's really fascinating to think about crypto operations and this idea as SmartNICs becoming this root of trust. And then I'd like to move into like how that might change service mesh as we perceive it.
So that's a really great thought process and kind of ties in this telco conversation. One of VMware's challenges is that the way that they license VMware ESXi on premises really isn't telco friendly, especially when you look at 5G and the density of how 5G will be deployed. And I don't think this type of application is a far stretch. If you're in a football field, doesn't matter if the football field is football US, football UK, these places hold a lot of people. And one of the advantages or promises of 5G is the ability to pack a lot of radios into a really dense area. So let's say that you're in a football field that holds 100,000 people. You have 200 to 500 access points that have that all have SmartNICs in it. So physically, the access points may not be bigger than an Intel NUC, just as long as they're powerful enough to have the control plane software and the 5G NIC, the 5G radio, and then the SmartNIC installed, then it should suffice for that use case. But if you have a SmartNIC in there, that's an awful lot of capacity just to handle radio connections back and forth to the 5G network. There's an awful lot of SS capacity left. What if the telco provider could sell that excess capacity to a fantasy football league?
Mm.
That becomes interesting. How do you secure it?
Mm.
Well, if I have cryptography running on the SmartNIC and authentication, I can, and then virtualization has already been proven as a way to an extremely secure way to provide multi-homed access to the same physical sets of equipment. Now I'm thinking about service mesh a little bit differently, and I'm thinking about SmartNICs a little bit differently because I'm using this precious access that's 5G compute power, and I'm creating applications like fantasy football that's based off of location of the 5G uh, endpoint based on their position in the football arena. Gets to be, and I'm not an application developer, and I can think of these types of things that I would love to do. Pokemon Go, etc., all these geofence type applications that I would love to build, but I need it to be co-located with the connectivity.
So what this starts to get us to, I think, is, and one of the points that Andres makes is that maybe we need service mesh technologies that are more narrowly defined than you might see now in something like Istio, where you have so many capabilities to use it, where you might just have, for instance, a service mesh as like an identity control plane.
Mm-hmm.
And he thinks we're starting to see that to some degree. In GitHub has a service mesh now that is looking like it could have a role of similarity, kind of a similar use case.
Yeah, I love to talk to some of these architects to think through how they're thinking through how they handle the control plane from a operator's perspective. Like, I physically have 500 nodes and I need to update the operating system of the 500 nodes, like physical control plane, and making sure that the firmware is up to date, the hypervisors up to date, etc. So there's the management of the control plane, authentication as it relates to allowing folks there, and then there's the resources that the control plane controls, and what resources I'm going to make frontward facing towards my customers. So there's the back office and the front office, and then that front office use case, that front end. What do I want as a service provider? What do I want to sell as a service, and how do I offer that up? How do I make that aware and to customers? How do I use authentication across multiple customers? If there's if you're on my service mesh or you're a customer of my service mesh, should there be federation between my application providers? So a football fantasy team and a gambling service, should there be a single set of authentication between that? Should we share tokens, or should these be isolated instances that run completely parallel to each other? So there's a lot of interesting decisions that I don't have enough visibility in, but I'm sure these conversations are happening.
Yeah, I'm sure they're happening too, because one of the things that we do start to see is like, it makes sense that you would use a service like AWS, right? Or Azure, whatever cloud service you want to use, right? You'll have different needs, different requirements, whatever the case may be. And, for most organizations, have had or, a data center, or they still use a data center, right? So this story about SmartNICs makes a lot of sense to me, because now if you're starting to be able to offload this really complex task of identity, right? And being able to then offload it to the hardware. It's especially as you start moving into more discussions about Kubernetes, right? Now you're getting into this space where now you have to think about, well, how do I manage all this? How am I possibly going to do that? And so, hybrid is hard enough, but then when you start adding, nodes out on the edge to this discussion, it becomes a whole nother challenge. And so this is why it makes sense to me that you're starting to hear about these lightweight service mesh environments. Emissary is the GitHub example. And what we're starting to see too is service mesh technologies that are getting built from Envoy that have limited functions. There's a project in the CNCF called Cilium, and Cilium, is one that might fit into this role. And IBM is starting to build out more of these lightweight services. And it's interesting, isn't it? Because it's I thought, oh, okay, well, there's a reason why Istio has everything underneath the sun. But we may be just seeing the first generation of service mesh kind of coming, and in many ways due to the advent of SmartNIC technologies.
It's really interesting. Let's pick on something that hasn't come to fruition yet, which is oh God, why did IBM is big in the, not Bitcoin, but the protocol.
Oh yeah, blockchain.
Yeah, blockchain.
Yeah, Hyperledger.
Yeah, immutable ledgers, etc.
Yeah.
So thinking about service meshes, and the IBM, I'm sure, is thinking around a service mesh just around blockchain.
Right.
The services that are just there to enable immutable ledger. IBM is super interested in this ability to do cryptography basically at the network layer. Mm. So if SmartNICs can help settle blockchain transactions faster, or help with identity from not from is this Keith, but is this process the process that it claims to be, or is this service? And there's a difference between a service and a process. Is this service what it claims to be, not just from a technical layer, but tracing all the way back from a business layer? Is this contracting service the actual contracting service that it claims to be? How do we make that invisible to the developer? So as a developer, I'm calling on this microservice provided by the network because of SmartNICs. I discover it via the service mesh, and I consume it via the service mesh, but I'm just making API calls, and all of it happens magically.
Mm-hmm. Let's move over to talk about a little bit about Intel, kind of to finish things up, because we had a conversation with some of the subject matter experts over at Intel. We had a conversation with Vinod Kumar, who's a senior network software engineer at Intel, and David Sisson, who's a solutions architect there as well. And one of the interesting aspects of this conversation that we had is how much respect they have for NSX, and how core that is to what what we're seeing here, for instance, just with with VMware. And one of the things they talked about how identity is a challenge, and how you can address the problem. You were asking about Lambda functions, and and asking to take them through how that would work. The other thing that they were talking about, which I really find interesting, is how we're starting to see the collapse of the network itself. Because now what we're seeing is, in their words, Cisco is good at routing and switches. Up the stack, you have Palo Alto Networks. For load balancing, you might have F5. Everyone has their niche point. And now you get the NSX, and it's like this off the shelf server. You get all the layers built into one. So what is the Intel role there? What is the Intel story in the midst of this? They acquired Barefoot, right? For instance, and maybe you could just talk a little bit about that Intel angle here, because I'm curious about it.
So Intel basically has 3 layers of this story that they can operate in. They can operate in not necessarily the SmartNIC, but a clever NIC. So we're talking about the 800 series ADQ, their processor or chipset that they put on their super powerful NICs that are slightly programmable, but for the most part are just meant to offload network functions. Then you have their SmartNIC. I think that's more like a 3000 series, which is the range of products that we were just talking about. That's completely programmable stuff that Project Monterey will run on. And then there's the network. There's the top of rack switch, which you plug your physical servers into, whether it's a 25 gigabit connection, or I'm not sure if Barefoot has 100 gigabit connection yet, but basically your transport layer between physical servers. Intel has products all the way from that low end all the way up to the high end, and for the most part, all of that is programmable.
Mm-hmm.
So when you tie something like an NSX into it, you start to eliminate what we've called as the merchant silicon, or the vendor silicon advantage, where where Cisco and Broadcom and think Mellanox for a little bit plays in this arena, and you start to, just like x86, commoditize the network processing layer. So you can have a protocol. Someone can write a cryptography protocol that will run on the 800 series, on the super smart NICs, and then on the network NICs. And this cryptography program might be optimized to encrypt images, or to validate or timestamp for deep fakes. I love this example. Analyze for deep fakes within the network. This is super advanced, and I don't know if anyone's really talked about this yet, but technically it's possible to write an algorithm that works at the network layer that detects deep fakes in videos, because you're starting to erase the difference between the network and the server, and you're using the data center itself as a single layer of compute. You couple this with Intel's PMEM, which is their persistent memory, Intel Optane SSDs,
Mm-hmm.
which increases I/O, and this I/O is closest to the compute, which is the SmartNIC, and the P4 networking going on in Barefoot. Today, P4, which is at the Barefoot top of rack layer, really isn't exposed to your typical Kubernetes type developer. but there's technically nothing stopping someone from going and downloading the P4 programming language and thinking through how they would design this type of workflow.
And that's where you get into, I think, the interesting intersection with VMware, right?
Yes.
Because they have like a who's who of open source leaders now, between people like Joe Beta and Craig McCluskey. Andres, I would put into that category. They basically have the pivotal team over there now too, and they had some great people in that group.
They just promoted Brian Lau who came over as a senior staff engineer from the Heptio acquisition, part of Joe Beta's old team. They promoted him into a principal engineer working in the telco space. So, he was able to look at Kubernetes big picture, and he brings that Kubernetes big picture from an engineer perspective over into the telco space. So these ideas that I'm just shooting out, he's kind of making that stuff real and tackling it from a person who actually knows how to code, knows how to work with partners, etc. So VMware relationship with Intel, the x86, we at the beginning of the year, I did a sponsored piece for Intel, which basically talked about why look at Intel, why is it just not about the processors? And this story around SmartNICs, this story around I/O when it comes to storage and memory, and the chipset around the CPU, this is where the holistic hybrid infrastructure story starts to become credible for Intel, at least.
And this is to me where I believe that Intel has its best opportunity. I have historically been skeptical of Intel and its developer focus, and that hasn't changed a lot. But my feeling is that if the more that we see kind of open source emerge, and the more we see people like Brian Lyle, helping tell the story effectively and helping really influence the telcos, right? For instance, that's going to be a game changer. And
from a holistic perspective, if a cloud provider had an all Intel stack, think about the telemetry data that you can get off of the entire system when it comes to observability,
right?
And how frustrating from a developer and DevOps perspective it is that you have noisy neighbors, and auto scale is great, but I want indicators. I want to know if it was noisy neighbors that caused my problem, or is it inefficiency in my code that's the problem? If I could get telemetry data off of the system, and that telemetry data is provided by all Intel stack, now Intel starts to make a stronger case. But Intel needs to move on that capability. They need these VMware partnerships. They need this deep layer of integration with the infrastructure and the software, so that developers can get this type of value from a all Intel stack.
Keith, I really look forward to keeping on this thread about this intersection of hardware and software with application development. I've learned so much in the past week just exploring this topic about service mesh and giving me just a new perspective on it. And so I want to, maybe what we can do in just a few minutes is talk about topics that we'd like to explore further. I would love to talk to more people in the service mesh space, and I'm writing a post about it right now, so I'll reach out to them. I'm also interested in the other cloud native projects out there, and how they're impacted by these, these developments at the edge. Is there anything for you in particular? You're the one who really came and said, "Let's do service mesh." So, like, what's your real view on this?
Well, I love the conversation around service mesh. I love, we've made this investment in a hybrid data center, and one of the secondary findings that we found, or discovered is that multi-cloud is hard. And I don't mean running multi-cloud across the same application across multiple clouds. I'm talking about just I have Kubernetes running on each cloud, and I want to take a application, import it from one cloud to another. On surface, that sounds solid. We consumed each of the major VMware cloud providers, and while we were confident in our ability to manage each VMware installation, we still ran into like separate issues or completely different approaches to how each cloud provider approached deploying VMware, which impacted our operations. And what I'm hearing from the Kubernetes people is that they're having the same challenges. That it's not just about, yeah, sure, the application developer can just write the application, but from an operator perspective, it's not just as simply as taking that YAML and the container and deploying it on another cloud provider. There's a level of complexity that's there. And I want to know how VMware, I want to know how Intel, HPE, how all of these companies in the ecosystem, how open source projects are helping me solve these problems.
Right. Because they're all about scale, right?
Yeah.
They're all about scale. And, another kind of, I think, angle on that is not just the scale of the data, but the scale of users and the scale of business groups and the scale out when you have not just 5 clusters, but now you have 10 or 20 or 50 or 100 or 200. And that's when you start to really that's when you really start to kind of come into challenges with multi-tenancy, for instance, right? And from what I understand, this multi-tenancy and isolation, and were big parts of why the hyperscale providers really invested in SmartNICs, back in the day. So I'm right with you, Keith. This has been a lot of fun.
Oh yeah, this was about as fun as I think we thought it would be. There's still a ton I don't know yet. This whole, the concept of the service mesh integrating directly with the SmartNIC. I think as we've talked to the experts, they've kind of been like, Alex and Keith, you guys are kind of crazy, but as you've discovered, this is, there's potential there, and I'd love to hear how this conversation progresses.
Yeah, I think it's gonna be a lot of fun, and so we'll do these on a regular basis. I think we'll be looking a lot at the conferences that are coming up, where we can use as a contextual perspective. And I think there's topics on the physical infrastructure side that I'm really looking at in terms of how we intersect with software development, which is really what we focus on at the new stack. For instance, Intel Optane, and all that it offers. So thanks again, Keith, and I look forward to having another conversation with you soon.
Thanks for hosting this, Alex.